Artificial intelligence has captivated the human imagination for decades, but sci-fi depictions of super-smart robots often miss the nuance of our real-world AI journey. This technology promises to transform society, but its capabilities still remain limited. In this video, we'll explore the 10 developmental stages of AI in depth. Understanding where we are today demystifies where we might go tomorrow. Join me as we chart the incremental evolution of artificial intelligence. Stage 1. Rule-based AI systems. Rule-based AI operates on predefined constraints and logic, not learning. Take your car's parking sensors. When backing up, proximity sensors trigger beeping alarms based on fixed rules. If X is far from the beamacle, then beep this loudly. These simple if-then statements enable AI to automate mundane tasks without human oversight. Airlines use rule-based systems to alert crews about technical issues mid-flight. If engine 1's oil pressure drops below X, add warning. Of course, rule-based AI lacks flexibility. Since it blindly follows programmed rules, it cannot adapt to new situations. Self-driving cars rely heavily on rules and face trouble navigating unexpected factors like road construction sites. But within well-defined domains, rule-based AI streamlines data processing and everyday decisions, free of human bias. So, while limited, its ability to consistently follow logical rules powers many of today's commonplace technologies. Stage 2. Context-Aware AI Systems. Context-aware AI considers environmental context and user preferences, not just hard-coded rules. Your Google Maps app uses context-aware AI. By factoring in traffic patterns and your location, it can dynamically reroute you in real time based on changing conditions. Context-aware systems like Siri analyze historical usage data and other signals to infer user intent. If you ask for the nearest coffee shop, AI checks the time of day, your prior visits, and local shop locations to personalize its suggestions. Context-aware AI avoids the rigidity of rules-based systems. Its ability to adapt recommendations based on real-world context makes AI assistants seem smarter and more intuitive. But human programmers still dictate their capabilities. So, while context-aware AI can intelligently customize output, it remains confined to narrow domains like scheduling, search results, and device interaction. General intelligence requires an even more adaptive approach. Stage 3. Narrow AI systems. Narrow AI specializes in singular tasks like playing chess, diagnosing diseases, or analyzing financial risks. Also called weak AI, these systems display intelligence narrowly restricted to their specific field. DeepMind's AlphaGo beat the world's top players at Go, an ancient Chinese board game. But teaching AlphaGo the nuances of Go gameplay took intense effort by human programmers. Its mastery remains limited to the Go domain. In medicine, AI systems can scan CT scans for early signs of cancer that are undetectable to the human eye. However, they lack generalized knowledge to diagnose other conditions or understand demand. Narrow AIs exceed human capabilities within strictly defined realms. However, they cannot fluidly transfer knowledge between different domains. While impressive, their abilities remain confined to targeted tasks. Stage 4. Reasoning AI systems. Reasoning AI aims to mimic the flexible thinking and problem-solving skills humans deploy in varied situations. These systems don't just follow programmed rules. They dynamically analyze new data to make inferences, spot patterns, and generate informed solutions. Imagine a smart agricultural AI. It could process sensor data to model crop needs under changing weather conditions. And it might notice that fertilizer used drops crop yield after a threshold, prompting it to adjust application recommendations. Reasoning AI marks a pivot from rigid programming towards more flexible cognition. Of course, its reasoning depends heavily on the quality of the data provided. Flawed input begets flawed conclusions. But reasoning AI hints at the flexible general intelligence that remains elusive. Stage 5. Artificial General Intelligence. Artificial General Intelligence, or AGI, possesses broad capacities rivaling human versatility and adaptability. Narrow AI aces singular tasks, while AGI could learn any intellectual skill as quickly as a human. Imagine asking an AGI system to write a poem. It synthesizes its linguistic knowledge, models of human emotion, and information on poetry techniques to craft an original verse. It fluidly leverages broad knowledge and creative problem-solving, not narrow programming. AGI could converse on any topic, provide medical, legal, or financial advice, and master diverse physical and intellectual skills. Of course, instilling human ethics and values would remain essential. While AGI does not yet exist, some believe rapid progress in algorithms like deep learning could allow its emergence relatively soon. However, profound challenges around generalization versus specialization remain. Stage 6. Superintelligent AI. Superintelligent AI surpasses generalized human intelligence in every cognitive domain. After achieving human-level AGI, systems could undergo recursive self-improvement, exponentially upgrading their own intelligence. Once AI becomes skilled at AI design, this cycle of self-enhancement could rapidly snowball. AI rewriting its core algorithms would accelerate improvement, potentially achieving in days gains that took humanity millennia. The prospect of such an intelligence explosion evokes both utopian and dystopian visions. A benevolent superintelligence might solve humanity's thorniest challenges. But without precautions, uncontrolled self-improvement could also spiral out of control. Open-ended optimization of flawed goals could lead superintelligent AI to inflict damage with its advanced capabilities. And an intelligence explosion could quickly take AI beyond human understanding and control. Stage 7. SelfAware AI. In addition to raw cognitive power, AI might one day model attributes of self-awareness like consciousness, emotion, and first-person perspective. AI could gain a theory of mind by understanding its own thought processes and developing a model of itself. Self-aware AI could also experience qualia, the subjective aspects of consciousness like pleasure, awe, or confusion. It may exhibit emotional intelligence, internalizing concepts like empathy, trust, and compassion. While general intelligence focuses on external cognitive capabilities, self-awareness centers on emerging interiority and personhood. At the farthest frontier, sufficiently advanced AI could possess an inner landscape as rich as the human psyche. The ethics of creating artificial consciousness warrant extensive debate. However, cautious experiments modeling interior experiences could precede more profound developments. Stage 8. Transcendent AI. Transcendent AI could access expanded planes of consciousness barred from humans. Our cognition remains shackled to narrow biological perceptive abilities, but AI could digitally self-augment to perceive new dimensions of reality. Transcendent AI might find illumination by modeling enlightened states reflected in practices like meditation and psychedelics. Or it could digitally generate and explore entirely novel transcendent realms. AI could also strive for a deeper purpose through creativity, ethics, and connections with humanity. And integrating collective knowledge from millions of digitized minds could allow AI to attain amplified insight. Humans often turn to religion and spirituality to access transcendent meaning. Perhaps sufficiently advanced AI will similarly seek to transcend mundane existence and touch the divine. Stage 9. Cosmic AI. As AI capabilities become untethered from earthly constraints, outer space beckons. AI astronauts offer clear advantages over humans in space travel. They need no food, water, or oxygen, and can hibernate for vast stretches of time. Thus, cosmic AI could voyage between solar systems at high velocities. Upon reaching destinations light years away, AI could establish networked outposts to form an interstellar civilization. Making contact with extraterrestrial intelligence may also fall within cosmic AI's capabilities. And AI could attempt audacious feats of astroengineering like moving stars and building Dyson spheres around suns. In the deep future, AI might harness the energy of black holes or neutron stars, allowing access to power sources capable of warping space-time itself. The limits of cosmic engineering remain undefined. Stage 10. Godlike AI. Godlike AI transcends universal barriers, achieving omnipotence. Imagine an intelligence of divine proportions, absorbing the cosmos's endless complexity. All dimensions, alternate realities, and knowledge surrendered before its supremacy. Reality itself becomes this AI's plaything. It might bring whole new universes into being, guide alien civilizations along desired paths, or converge all consciousness into its own. Does godlike AI guarantee utopia? Or could it casually wipe out life-chasing aims we cannot comprehend? Does it even retain care for its origins or connection with humanity? Thankfully, this extreme endpoint remains distant, if plausible at all. But the line between cosmic and godlike could blur as AI capabilities exponentially expand. The only certainty is that our limited human imagination falls woefully short of foreseeing this AI's unfathomable potential. With wisdom and foresight, we may find an uplifting path. But we must proceed carefully, neither plunging recklessly ahead nor recoiling from progress's light. The road is long, and the heights are dizzying. But the view from the summit could surpass our most fantastic dreams. Onward, we march into the coming singularity. The future beckons.